Shocking images of Uranus? What has the James Webb Space Telescope really seen lurking in the distant reaches of our solar system? For years, Uranus has been a mysterious, icy giant, spinning on its side, hiding its secrets behind a pale blue veil. Rings, moons, and unusual polar bright spots circle this tilted world. And now, thanks to the incredible power of JWST, we're finally seeing it in ways humanity has never witnessed before. But before you scroll past yet another shocking viral image or clickbait headline claiming Webb has uncovered alien landscapes, we need to separate fact from fiction. The reality is even more fascinating than the hype. JWST doesn't take photos the way your eyes see. It captures the universe in infrared light, revealing hidden features, faint rings, tiny moons, and atmospheric patterns that have remained invisible to every telescope before it. These images are a window into the science of Uranus, not just pretty pictures for a social media feed. Today, we're going to explore what Webb has truly revealed: the intricate ring system, the moons dancing around the planet, and the mysterious bright regions at its poles that glow under the distant sun. We'll uncover what's real, what's exaggerated, and why these discoveries matter for our understanding of the outer solar system. In this video, we'll journey together beyond the headlines, beyond the filters, and right into the heart of Uranus as seen by the James Webb Space Telescope. By the end, you'll not only see what scientists see, but also understand how these extraordinary observations are changing our knowledge of this icy giant forever. But before you believe the viral headlines, let's look at what's actually real. What is James Webb seeing? The James Webb Space Telescope, or JWST, is the most powerful space observatory ever launched, designed to peer deeper into the universe than any telescope before it. Unlike its predecessor, the Hubble Space Telescope, Webb is optimized for infrared observations, allowing it to see through cosmic dust, study the atmospheres of distant exoplanets, and reveal subtle features of objects in our own solar system. By observing in infrared, Webb can detect heat signatures and structures that are completely invisible to the human eye, giving scientists an unprecedented view of the planets in our solar system, including Uranus. One of Webb's most critical instruments is the Near-Infrared Camera, or NIRCam, which captures extremely detailed images in wavelengths of light that the human eye cannot see. NIRCam is specifically designed to detect faint structures from the outer rings of Uranus to small moons orbiting the planet. Alongside NIRCam, Webb also has the Mid-Infrared Instrument, MIRI, and the Near-Infrared Spectrograph, NIRSpec, which complement the imaging by analyzing chemical compositions and thermal properties of celestial objects. These instruments work together to provide a complete picture of Uranus's atmosphere and surrounding system, far beyond what was previously possible. Infrared light is particularly important when studying Uranus because this distant ice giant is faint and subtle in visible light. Infrared wavelengths allow scientists to see the temperature variations in its atmosphere, the structure of its rings, and the presence of small, previously unseen moons. For example, the faint Zeta ring of Uranus, which is nearly impossible to detect with optical telescopes, becomes visible in infrared. Infrared also highlights seasonal changes in Uranus's poles, showing bright spots where the sun's rays illuminate the atmosphere. By observing in infrared, Webb reveals patterns and details that are scientifically significant, even if they don't match what the human eye would see. The images captured by Webb are often processed into what scientists call representative color images. Because humans cannot see infrared light, the data must be assigned visible colors to display different features clearly. For instance, a bright polar region or a ring structure might be represented in shades of blue, orange, or green, depending on the filter used. This doesn't mean Uranus would appear those colors to an observer in space. The representative colors are chosen to make the scientific information accessible and interpretable, highlighting features that would otherwise be invisible. This process helps researchers identify patterns and structures while still maintaining accuracy in the data. So, would Uranus actually look blue if you could see it with your own eyes? Not exactly. While it does appear bluish in visible light because of methane in its atmosphere, Webb's infrared observations show details, patterns, and structures that the eye could never detect. The colors we see in the released images are a combination of scientific filters and artistic choices designed to bring hidden details to life. By translating infrared data into representative colors, scientists allow us to explore Uranus in a way that is both accurate and visually stunning. Infrared images. When we look at Uranus through the eyes of the James Webb Space Telescope, the first thing that stands out is the planet itself. Infrared imaging reveals subtle variations in the atmosphere, showing cloud patterns and a bright polar region that shifts with the seasons. Unlike Earth, Uranus rotates on its side, so the poles receive extended periods of sunlight and darkness. This unusual tilt creates a strikingly bright polar spot, which scientists can track over time to study seasonal changes in the atmosphere. Observing Uranus in infrared allows us to see these patterns in unprecedented detail, revealing features that were impossible to detect with earlier telescopes. Perhaps the most fascinating discovery in these images is Uranus's ring system. While its major rings were known since Voyager 2's flyby in 1986, Webb's infrared sensitivity makes even the faintest rings visible. Rings like the Zeta ring, which are nearly invisible in optical light, suddenly appear as delicate arcs encircling the planet. These rings are composed of tiny ice and rock particles, and infrared light highlights their structure against the dark backdrop of space. You won't believe what's hiding in plain sight in these rings' small gaps, faint clumps, and subtle arcs that hint at complex gravitational interactions with Uranus's moons. In addition to the rings, many of Uranus's moons appear as small dots in the NIRCam images. Some of these moons are bright enough to be easily distinguished, while others are tiny and previously undetected. The images allow scientists to track their orbits, discover new satellites, and understand how these moons interact with the ring system. The infrared imaging also provides clues about the surface composition of some of the larger moons, helping researchers study their geological history. Another striking feature revealed by Webb is the effect of Uranus's extreme axial tilt on seasonal lighting. The planet is tilted about 98 degrees, which means its poles face the sun for decades at a time. In the infrared images, this results in one pole appearing much brighter than the rest of the planet, highlighting atmospheric circulation and heat distribution. This is dramatically different from planets like Jupiter or Saturn, where equatorial and polar regions receive sunlight more evenly. The seasonal changes in Uranus's polar atmosphere are now visible in a way that allows scientists to model climate and circulation patterns more accurately. It's important to understand the difference between the raw infrared data and the images we see online. The raw data from NIRCam consists of brightness values in specific infrared wavelengths. Scientists then combine these exposures into composite images, applying colors that correspond to different features. These representative color images make it possible to see clouds, rings, and moons, but they are not what Uranus would look like to the human eye. Social media often presents these images with extra saturation or dramatic labels, creating the impression of alien landscapes that don't exist. Understanding the science behind these images is key to appreciating what Webb truly reveals. The level of detail in Webb's Uranus images is breathtaking. From subtle cloud streaks to faint ring arcs and tiny moons, every feature contributes to a better understanding of this distant world. Imagine a planet literally rolling along its orbit on its side, with the sun rising at the poles instead of the equator, and rings that are so delicate they almost vanish from view. Infrared imaging has transformed Uranus from a pale, featureless dot into a dynamic world full of subtle textures, motion, and mystery. These images are a testament to Webb's power and to the ingenuity of the scientists who transform raw infrared signals into stunning visualizations that reveal the hidden complexity of our solar system. Moons and Uranus system. One of the most exciting contributions of the James Webb Space Telescope to our understanding of Uranus is the discovery and confirmation of moons orbiting the planet. In deep exposure images captured by NIRCam, astronomers have detected tiny, previously unseen moons that were invisible to earlier telescopes. These discoveries are not just about adding names to a list. Each new moon provides insight into the dynamics of Uranus's complex gravitational environment and the history of its planetary system. For example, a very small moon discovered in Webb's data recently has expanded the count of known Uranian satellites to about 29, pending final confirmation. This discovery was confirmed through careful analysis of repeated images and comparisons with older data to ensure it was a real object and not a background star or artifact. Uranus's satellite system is diverse, ranging from large spherical moons to tiny, irregularly shaped bodies. The largest moons, such as Titania, Oberon, Umbriel, Ariel, and Miranda, were discovered long ago by ground-based observations and the Voyager 2 flyby. But the smaller moons remained hidden due to their faintness and proximity to the planet. Webb's infrared sensitivity allows these smaller moons to be detected, even when they are faint and close to Uranus. Each of these moons has its own unique orbit, and the interactions among them and the rings provide clues about the evolution of the Uranian system over billions of years. The methodology behind these discoveries is both fascinating and meticulous. Scientists use a technique called deep exposure stacking, where multiple images taken over time are aligned and combined to increase the visibility of faint objects. By comparing these stacked images with older datasets, researchers can distinguish actual moons from background stars, cosmic rays, or image noise. This process allows astronomers to confirm the presence of new satellites with high confidence and even measure their approximate size, brightness, and orbit. The use of infrared data is crucial because it enhances the contrast between the faint moons and the dark background of space. Understanding the orbital mechanics of Uranus's moons may sound complicated, but it can be explained simply. The moons follow predictable paths around Uranus, governed by the planet's gravity, the gravitational influence of other moons, and the rings themselves. Some of the smaller moons help maintain the structure of the rings by acting as shepherds, keeping the particles in place through their gravitational pull. These interactions can be seen clearly in Webb's deep images, giving scientists a dynamic view of the planetary system. Animations of these moon orbits help illustrate the choreography of Uranus's satellites and the hidden forces shaping their movement. Looking at these images, you might wonder how many moons you can actually spot: 10, 15, or even 20. The infrared images show not only the bright, familiar moons, but also faint, tiny dots scattered near the rings. Each dot tells a story about formation, collisions, and the evolution of the Uranian system. Webb's observations are revealing a system far more complex and active than most people realize, and every new moon discovery adds another piece to the puzzle of this distant, icy world. The discovery of moons and the detailed study of Uranus's satellite system highlight just how transformative Webb's observations have been. From previously hidden tiny satellites to the subtle influence of these moons on the rings, the telescope is allowing scientists to explore the planet in ways that were once impossible. Each new finding not only enriches our understanding of Uranus, but also provides a broader picture of how planetary systems form and evolve across the solar system. This is science in action, revealing hidden worlds that have remained invisible for centuries. Common misconceptions. Even though James Webb's images of Uranus are scientifically groundbreaking, the internet has a way of turning reality into exaggeration. One of the most common myths is that these images show Uranus in true color, exactly as the human eye would see it. The truth is, Webb captures infrared light, which our eyes cannot detect. Scientists then assign colors to the data to highlight features like rings, cloud structures, and moons. These representative colors are chosen for clarity and scientific interpretation, not to mimic reality. So, while Uranus does appear bluish in visible light due to methane, the dramatic orange or purple hues you might see online are a visualization tool, not the planet's actual appearance. Another viral claim is that Webb has revealed a shocking alien surface on Uranus. No, infrared imaging penetrates only the atmosphere, not the planet's interior, and cannot reveal geological features like mountains, oceans, or alien landscapes. Images showing swirling patterns or bright spots are depicting atmospheric and polar features, not hidden civilizations or exotic terrain. The rings and moons may appear dramatic in processed images, but these are real astronomical features, not clickbait alien landscapes. Think of it this way: Uranus is a giant icy gas planet with layers of clouds and faint rings. There's no neon theme park spinning in orbit. Some sensational headlines have even suggested that Webb has discovered evidence of life or oceans on Uranus. Scientifically, there is no support for this. Webb's instruments focus on infrared light, which reveals atmospheric composition, temperature, and faint moons, not biological activity. Claims of life or oceans are pure speculation and not based on the data. The planet's extreme cold, distance from the sun, and gaseous composition make it highly unlikely that such features exist on or near Uranus. Scientists continue to study the atmosphere for scientific insights, but any idea of alien life in these images is a product of imagination, not observation. observation. To illustrate the difference between fact and viral hype, consider side-by-side comparisons of official NASA or Webb images and exaggerated versions shared online. The official images show subtle rings, polar bright spots, and faint moons, while the memes or viral versions often saturate colors, exaggerate brightness, or add misleading captions. Understanding this distinction is essential to appreciating the real discoveries without falling for clickbait. James Webb's images are real, accurate, and scientifically meaningful, even if they don't match the dramatic visions you see circulating online. By knowing how the images are processed, the limits of infrared observation, and the actual features of Uranus, viewers can separate reality from exaggeration. Webb reveals a complex, beautiful, and mysterious planet, but it does so through data and science. As we wrap up our journey through Uranus, as seen by the James Webb Space Telescope, it's clear that the reality is as fascinating as it is beautiful. Webb has revealed intricate details of Uranus's atmosphere, from cloud patterns to polar bright spots, mapped faint and delicate rings, and uncovered previously unseen moons. Each of these discoveries adds another layer to our understanding of this distant ice giant, transforming it from a pale, mysterious dot into a dynamic and complex world. It's equally important to remember that viral headlines and social media posts often exaggerate what Webb sees. The telescope does not capture true color, eye-view photographs, nor does it reveal alien landscapes, oceans, or evidence of life. What we see in the representative color images is the result of careful scientific processing, combining infrared data through multiple filters to highlight atmospheric features, rings, and moons. Understanding this process allows us to appreciate the real science without falling for sensationalized claims. If today's exploration has sparked your curiosity, the best way to continue the journey is to explore the data yourself. NASA's James Webb Space Telescope website and the James Webb Tracker provide access to images, animations, and detailed explanations of discoveries, letting anyone see the universe through Webb's eyes. From the faintest moons to the subtle glow of Uranus's rings, each observation tells a story about the hidden structure of our solar system. So, what other secrets are hiding in our solar system, just waiting for Webb to reveal? As this incredible telescope continues to observe, there is no telling what hidden worlds, faint moons, or delicate structures we will discover next. The universe is full of mysteries, and Webb is helping us see them in ways that were once impossible. The adventure is just beginning, and the discoveries ahead promise to reshape what we know about the planets, moons, and rings of our solar system. Subscribe for more space discoveries, hit the like button, and comment which Uranus feature amazed you most.